So HCI focuses on design, among other things. Now, when designing, always remember that you're designing for the user and that you are not the user. This is important for software developers to remember. Just because you can figure something out or something makes sense to you, that doesn't mean it's going to make sense to anyone else or that anyone else will be able to figure it out if they're not a programmer themselves. And so we've got this interesting comic here sort of pointing out that when one group designs and makes assumptions about what sorts of understanding and abilities people are going to bring to the table, that may not be true for the people actually using the system. So there's sort of an interesting question, what is a computer? So suppose we want to, boil down the concept of the computer to its essence. So, what might we come up with? So think about that for a moment here. What is a computer? Like fundamentally, basically, what's a computer? So essentially whatever you come up with is probably going to be pretty accurate because you're probably a computer science major or minor and you kind of have a fairly good idea of what a computer is. There's a lot of different things you can come up with. It's a manifestation of an abstract Turing machine. It's a problem-solving instrument. It's a giant calculator. It's a thing that takes inputs and generates outputs. I don't know. You can come up with a lot of different things. But think about the reverse of that. So from the computer's perspective, suppose your computer is asking, well, what's a user? So what might the computer think about the user? So, one sort of funny possibility, from the computer's perspective, the user is really just this random input generation routine. Well, yeah, I've got this user process, and occasionally it bangs on the keyboard and types some stuff out, and it's not very accurate. So this user process is constantly going back and having to hit the backspace and delete things, and there's mouse movements, but they're kind of herky jerky and things like that. That's kind of what the user is from the computer's perspective. And I'm sure that the computer's thinking well, this weird user input routine, it's probably, a hidden Markov model with some finite state machine or something. Now, if we push this a little further, what might the computer think of the user? Well, you could imagine your devious computer saying, well, the user process is really good at deciphering the kind of inputs that I want, and this user process will eventually learn to give me the inputs only in the formats that I want. And from the computer's perspective, the computer doesn't really care if it takes the user a long time to learn the inputs that I want. It's a computer. The computer can, while true, wait for input as well as any user process, probably for longer. Computers don't get bored. And so this is kind of a funny example, but there's some truth to this. And so what's wrong with this mode of thinking? If the computer is allowed to think of the user as this input generating routine that will eventually learn what the right types of inputs are. Well, let's think about some of the ways that we've been trained to understand what inputs we're looking for. Now, we know how to Google things to get the desired results. So if we want to know, Tom Cruise's net worth, we type into the Google net worth Tom Cruise, it'll spit this out. If you're talking to somebody and you're having a conversation and you'd like to ask them a question like, what is Tom Cruise's net worth? You don't just go up to them and say, net worth Tom Cruise! If you want to know how to drive from, get driving directions to drive from, Galesburg to, Miami, you're not just going to walk to somebody and say, directions Galesburg, Illinois, Miami, Florida, go! You're going to have a conversation. You're going to say, how are you? What are you up to? I'm wondering if you could help me with directions. Right? When humans interact, you don't just go up to people and start spitting out keywords that are likely to trigger the reaction that you're looking for. But that's what Google's trained us to do. People who have good Google foo, that's what they're good at. And I realize Google's put a lot of effort now into understanding sort of common question patterns and frameworks. And if you say what is or where is or something like that, Google knows what you're asking and uses that context to do a better job of handling your search. I understand that, but fundamentally, if you've got good Google foo, good Google skills, you can still just sit there and pound out more or fewer keywords until you get what you want. Most people that are good with search engines kind of understand this, but it's important to note that This is because you've been trained by search engines how to use a search engine. It's not because the search engine has figured out how to interact with humans the way that humans interact with each other, right? You don't walk up to people you know and just start spitting keywords at them until they do what you want or answer the question. Well, at least I hope you don't interact with other people that way. So here's some, interesting examples of ways in which users have been trained to do the right thing, even if it doesn't necessarily make sense. Whenever you need to change your password, it always annoys the heck out of me when I go to this page that there's this little box here, and of course the right thing to do is not to log in. To reset your password, you're supposed to click up here where it says click here to reset your password. Well, if I'm going to this page and that's what I'm going to do, why is this here? This is not good user, there's a thing that I want to do whenever I see stuff like this, but that's what I'm supposed to do. That's kind of confusing. I've been trained, so when I change my password, I know what to do, but it's not the natural thing that I want to do on that page. Here's another, example. This is just like a transcript of a terminal session I was doing with my terminal on Mac. This is from several years ago, so you type, cd nox/cs262. I'm trying to get into my 262 directory, and if it's no such file or directory, you get back, okay, no such file or directory. It'll give you an error message. If I type cd nox 262 f11, that's the correct name of the directory. This is just echoing the command. If I don't get any output, that means that it worked. And I type ls, and then I get, my output, whatever. The fact that when a command works, it doesn't do anything, you just have to know that means it worked, that's a little bit confusing. Now, people that have been using command lines for a long time just kind of understand that. But when you're first using a command line, you type in a command like cd or mkdir or something like that, and you don't get any feedback. You're kind of like, well, what happened? Well, no feedback means it worked, which is a little bit bizarre. The old Nox website, so the new website's been changed around, it's been reskinned. The old website had this problem. Where's the apply button? Look at it for a second. There it is. There were a lot of problems. We actually were able to see this in the data that was available through the Google Analytics account. You could see that people got to the apply button, but often they were on a page that had an apply button, and they would go click on prospective students and sort of find the link that way. The apply button was here, but we're kind of trained to think of the frame around as, navigational stuff and advertisements, and the stuff in the middle to be the content. And because there was no apply button in the middle, we had some quantitative evidence that students, the apply button was there, but they weren't processing it mentally because we're so used to stuff over here being an advertisement. That was a really interesting thing that Nox CS Miner found a couple of years ago. So, this mode of thinking of sort of training people to understand your particular way that you did the user interface, this is bad user interface design. The human should need to learn as little as possible about the expected inputs, the expected formats, what the computer wants to use the program. You should have no unintuitive quirks if you can get away with it. The fewer unintuitive quirks, the better. So the take-home message here, you have to understand that your interface, your user interface, it completely structures the quality of interactions, the kinds of interactions that the user can have with your program or with your system. Just because it's possible to accomplish something, it doesn't mean that your design is any good. And the last thing anybody ever wants to hear if you write software and it's really freaking hard to do something is, oh, well, it can be done. You just have to click here, then click there, then don't click there, then undo this, and blah, blah. No. If it's complicated and people tell you it's complicated and they don't understand how to do it, then you need to ask yourself, is this really the simplest way to do it? Maybe it is, and you're just working in a really complicated problem domain, and the people just have to learn. That's fine. But if it's possible to structure that interface to be simpler and more intuitive for the majority of your users to use, you need to seriously consider doing that, even if it's a lot more work for you. So HCI is not, or at least is not primarily about graphic design or, poorly worded error message or this debate about aesthetics or something like that. Graphic design is not unrelated to HCI because A lot of good designs rely on good graphic design, a good knowledge of layouts and things like that. But HCI is not the same as graphic design. It's not even necessarily that closely related. There's a specific reason for this. HCI measures things. You don't really measure aesthetics. I mean, maybe you try to measure aesthetics and things like that, but they're aesthetics. Some people prefer one thing, some people prefer another. Who's right? I don't really know. In HCI, a user interface design, it's better if users accomplish tasks measurably better. So better could mean faster, with fewer errors, or better in some other measurable way. But there's measurable difference. HCI is not graphic design. If you have two interfaces, and one of them, somebody tells you, well, look, this interface looks prettier, it looks better, it looks more intuitive, that may or may not be true, but I'm going to need to see data for you to be able to back that up. Okay, I'm going to need to see people try it with the first interface, and then people try it with the second interface. If the second interface is better, I'm going to need to see some difference. Now, if you're trying to measure the aesthetics, so you're doing like a survey and you're asking people which one they like more, and they like one design more, okay, fine. Then you can go with that design. But HCI is not primarily interested in the graphic design question, the aesthetics question. HCI is interested in measurable differences that actually are going to make people able to use the system better, more efficiently, more accurately, and so on. So let's talk about some design principles. We've got affordances, mental models, good mapping, making things visible, feedback, and causality. So affordances, this is from Norman's The Psychology of Everyday Things, which is a really, really interesting book. Looks at a whole bunch of everyday objects and talks about the psychology of them. So the affordances of objects convey messages about their possible uses, actions, and functions. This is a very famous example. If you come up to a door that has a bar that looks like this that you can push to open, what side do you push on? Do you push on the right side? Do you push on the left side? I have no idea. That object doesn't give you any affordances to let you know how to push on it. Now, this is a bar. It has exactly the same function, but it has an affordance on the right side, which is telling you, push over here. That's what affordances mean. This is important in interface design. You might have two different widgets, two different graphical units in your user interface, and it might be the case that one of them it's very clear how to use it, one of them it isn't clear how to use it. You want to err in the direction of things that have better, clearer affordances. So mental models, users probably have mental models for things like files and folders. So if you're going to design a system where file and folder mean something different other than the mental model people already have for files and folders, there's going to be a cost to people because it's bringing them out of the mental model they currently have and forcing them to think about something else. And so one way to think about this, what are some other mental models that users are likely to have, and what are some systems that break mental models that people might have? I'll give you a second to think about that. So with mappings, with these mental models, if you can map the actions that users need to take in your system to actions they'll be familiar with, this actually works really well. This allows people to create good mappings. So there's some good mappings to actions that users are going to already be familiar with. A good example, flipping screens in a smartphone for flipping pages or flipping screens or something like that. That's an action that users are used to taking with books that they've used all over their throughout their lives. So flipping things makes sense. Two-finger scrolling, this also makes sense, sort of pushing stuff up, pushing stuff down, two-finger scrolling with a touchpad or again with a smartphone. These are good mappings to a mental model that a person's already going to understand because that's how they interact with sort of physical objects anyway. Now there's a number of ubiquitous but possibly bad mappings. So what are actions users are familiar with that maybe don't cleanly map to other actions? I mean, there's kind of a lot of examples of this. I've got a couple in mind. Clicking on the Start button, this is kind of ubiquitous now, but it doesn't really make sense. Why is clicking on the Start button in Windows supposed to, bring up this menu with my programs in it, the start button. It's sort of weird, but that's now this ubiquitous mapping that a lot of people have, such that when you take that out in Windows 8, there's no more start button. People who are used to having a start button now find it very confusing. So now there's this association with, like, I need a little start button in Windows in the bottom left, or I don't know what the heck to do. Well, that doesn't really make any sense because the start button never made any sense anyway. So we've created this mapping that's now kind of bizarre. Other examples, my computer in Windows, when I want to see like what the heck is on the C drive, I'm like, okay, figure out how to bring up my computer. And it might vary from different versions of Windows, but I sort of expect there to be some kind of my computer to bring up some way to like browse the stuff that's on there. The other ones I'm always interested in are double clicking, which is now ubiquitous. You double click an icon to get it to start. You double click an icon to get that thing to open. You double click things to do stuff. You double click things in a lot of video games. And then right clicking to bring up property menus and things like that. These are mappings that are kind of ubiquitous for people, but they're not clean mappings that make a lot of sense in other contexts. But now at this point, if you were to have things where you don't double click to start or you don't right click to bring up a properties menu, people would find that very confusing. Just like if you have a version of Windows without a start button, people tend to find it very confusing. So we've created new mappings that are, I'm not entirely sure what to say they're based on. They kind of don't make a lot of sense. So you always want to make things visible. You don't want to hide things from the users without a good reason, especially feedback. And so for feedback, you can have visual feedback, you can have tactile feedback, you can have auditory feedback, you can have many kinds. You can have many kinds of feedback. So some examples: rumble controllers give you feedback, right? Your controller actually buzzes and rumbles when the earthquake hits in your video game or something. Clicking sound effects. If you sort of click a button on your laptop or whatever, you're running a program, sometimes you get a clicking sound effect. Buttons that look like they've been pressed in. So you've got this virtual thing here. It looks like you press the button. The button looks like it's been pressed in. This gives you sort of immediate visual feedback. You know what button's been pressed because it's shadowed differently, shaded differently, looks like it's been pushed. There's many more examples of giving people just little subtle bits of feedback, but that's extremely helpful because now people can just look at something and immediately know what state each of the buttons, each of the widgets, each of whatever is in. So causality is really important. It's actually really frustrating for users when things happen sort of seemingly at random. An example of this that drove people crazy back in the day with older versions of Microsoft Word was Clippy the paperclip. You'd be typing away doing something, and all of a sudden this whole little Clippy guy would pop up and be like, hey, it looks like you're writing a business letter. Can I suggest some things? And you're like, look, I don't know where you came from or why you're here, but I need you to just go away right now. This is my favorite spoof of this. Somebody's typing, Dear World, I just can't take it anymore, I've decided, and then Clippy pops up, looks like you're committing suicide, office assistant, sort of a really dark joke here, but just to sort of point out how, obtrusive Clippy the paperclip was, because there was no causality. I didn't ask for Clippy to pop up, it just seemingly at random, Clippy would pop up and start giving me all this advice about, what I might want to do with my document. Listen, Clippy, if I want your advice, I'll ask you for it, but don't just randomly show up and start asking me all these questions. I'm trying to just type a friggin' letter here. Come on, Clippy, chill. So I got the 8 golden rules of interface design from Ben Shneiderman. Full disclosure, totally took a class with Ben Shneiderman back in 2001, I think it was. So we got consistency, universal usability, informative feedback, dialogues that yield closure, preventing errors, easy reversal of action, internal locus of control, and reducing short-term memory load. I'll buzz through these real quick. So strive for consistency. Consistent sequence of action should be required in similar situations. Identical terminology should be used in prompts, menus, help screens. Consistent commands should be employed throughout an application. So, possible example here, look, you're going to have OK, cancel, and help, right? You need to pick where they're going to be. Is it going to be OK, cancel, help? Is it going to be OK, cancel, help? It's going to be OK, cancel, help, OK, cancel, help. Are they going to be vertical? Are they going to be horizontal? What's the spacing going to look like? Pick one layout and use it exactly the same way throughout your application. I shouldn't have to spend an extra half a second figuring out which friggin' button it is, and you should never change the order of buttons. That would just be awful, right? Be consistent. Otherwise, you know, like are you trying to confuse the user? Is this some weird Andy Kaufman-esque meta joke? What the hell's going on here? Just pick a layout and stick with it. You want to enable frequent users to use shortcuts. So you want to have, you know, nice, clean, clear ways to do things with menus and whatever else. But if you've got frequent users, expert users, you want to have macros or shortcuts or, you know, keyboard commands or something like that, so that experts can still use the same program but use it much more quickly, much more effectively. So the canonical example of this, you know, you bring up your menu, you've got all this exciting stuff here in your menu, but you notice you've got all these different keyboard shortcuts. So, you know, Control-C, Control-V, or, you know, Apple-C, Apple-V, these are the standard examples. Everybody knows you can get these under the Edit menu, but expert users, and actually pretty much everyone else in the world now as well, knows that Control-C and Control-V also cut and paste. You know, Control-A, Select All. There's all these standard mappings that people know. And then applications like different versions of Photoshop and different, you know, Cinema 4D and these other applications that do video editing and image editing and things like that. They have tons of different keyboard options and macros and things like that, and expert users are just very, very, very efficient with them. But novice users can still find all those same features. They just have to do it through the menus or through tutorials. So you always want to enable the frequent users to have these shortcuts. So you want to give informative feedback. So for every action, there should be some system feedback. You should know how long things are going to take. The classic example here is the little progress bar. Without the progress bar and without some sort of time estimate, it can be very, very, very confusing. Users don't really know how long they're going to be expected to sit there waiting. So you want to design your dialogue to yield closure, your sequences of actions. These should be organized into groups. It should be clear. You're at the beginning, you're at the middle, you're at the end. When you're finished with one stage of events and you move on to the other stage of events, you should be able to forget about whatever you were thinking about in the first stage of events, kind of clear your memory buffer, drop whatever contingency plans you might have had, and move on and get a clear indication that you're at the next step. Kind of an example of this, the new project wizard in Eclipse. So if you want to create a new Java project, you put the name of the project up here, choices about locations. It gives you a reasonable set of defaults. If you want to change, the Java JRE, you can. If you want to change stuff about the layout, you can. If you want to change your project working set, I actually have no idea what that is, but if you wanted to, you can. Now, once you've done this stuff, you can click Next to go to another stage of dialogues, go through that. Everything you've entered in here, you can now forget about. If you've changed the version of Java, if you've set the name, those things are now done. When you click Next, go to the next menu, you can worry about the stuff there, and when you're done, you click Finish, and it goes ahead and does everything. It's a nice staged process. You don't have to remember everything all at once. So you want to give simple error handling. As much as possible, you want to make the system designed in such a way that the user can't make serious errors. So if there's, this is especially true for input, right? Why detect that the user's made an input error if you can just design the interface such that it's not possible to make that error? Classic example here are calendars, right? Now, everybody loves to have the little drop-down calendar. You can sort of scroll through the months and years, pick the day. That's fantastic. But there's a whole bunch of other ways to do calendars. This is great. You've got the calendar. You can scroll through months. You've got all the days to pick from. That's awesome. This is another version where you can pick the month and pick the day, but a lot of these, the day just goes up to 31, so you could put in like February 31st, which is never going to be possible. Sometimes these are set up so February 31st would be eliminated. If you click February, it'll only go through 28 or something like that. That's a little better, but this is sort of clear. This works as well, right? Form fill in, but you could still type in something wrong. It would then have to try to point out that you've done something wrong. This is the worst over here. You're just expected to know what the fancy particular form it is. You're going to have to type it. This is sort of terrible. And so this is sort of a progression of things here, but not so good, fantastic, and then all these other things are kind of somewhere in between. So you want to permit easy reversal of actions. Undo, Control-Z, this is one of the great features. You're typing out a paper, you're typing out some code, you accidentally like highlight a bunch of stuff and delete a whole method, you didn't want to delete that method right away, Control-Z, undo. Whew, it's back. This is actually a really, really, really powerful option, and so you want to make sure that things can be undone. Otherwise, this can be really, really difficult if a user makes a mistake and they're not able to undo things. This is especially important for novice programmers. If you've noticed from BlueJ, you can tell files to save in BlueJ, but you don't really have to. And if you've ever done Red Room tutoring or something like that, you notice students always ask in 141, how do I save my files? And you're like, dude, it's BlueJ. Every single thing you do, it's just constantly saving that file. It's like virtually impossible to type anything into BlueJ and then somehow have it not be saved. It's always going to be saved. You might have saved it to the wrong place, right, such that when that machine reboots, it gets wiped out because you like somehow put it on the C drive and didn't follow the instructions. They're copiously written up everywhere to put it in your network drive on your Z drive. So you may not have paid attention to that part of it and put it somewhere where all your data gets wiped. That's not BlueJ's fault, though. BlueJ, it's like virtually impossible to lose anything in BlueJ. They don't even really have to worry about undo. They're just so good about making sure they save everything. So you want to support an internal locus of control. Operators of these systems, they want to feel that they're in command, even if they might not actually be in command. Now, there's like a really famous example of this. Have you ever noticed that up until the absolute last moment before your computer crashes, if you move the mouse around, the cursor will move around the screen? You know, I can always move the cursor no matter what's happening, even if the machine's about to crash. Why is that? Well, that's so that you think you're in control as long as possible. Anytime I try to move the cursor and I can't, I sort of feel like, oh my god, I'm no longer in control. This thing's about to crash. This is terrible. I get really, really nervous about that. But if I can move the cursor, at least I feel like I have some control. It's sort of bizarre, but this is actually psychologically important to people. Finally, reduce the short-term memory load whenever possible. So human information processing is fairly short. Short-term memory, you've got 7 items plus or minus 2 things. If there's multiple things people need to do, you want to stage it out as much as possible. You want to make sure that there are clear ways to cut down on the amount of stuff that people need to remember, as far as like special commands or special codes or special macros and things like that. There's a lot of stuff about what's called cognitive load theory, the idea that you have limited short-term memory, and if your short-term memory is full, that actually can hinder getting information into your long-term memory to help create those long-term memory connections, which is what you need to sort of get good at a program. This is why we don't start people out with Eclipse. We start people out with BlueJ or Dr. Java, something that's much simpler. We don't want a lot of things to sort of look complicated because we don't want to fill up people's short-term memory. That's never a good thing, especially for novices. So this is my favorite example here. If you want me to do something as a faculty member, or really just in general, when you're sending email, get the information into the email as clearly as possible, so I don't have to remember a whole bunch of stuff as I'm parsing through stuff. So for example, you need a rec letter. I want in the subject, let me know, rec letter, when's it due, what date, and then in the body of the email, whatever information I need, get that in there very clearly. So please remember my rec letter for the Imperial Academy is due Friday, 11/1. Email it to Governor Tarkin at deathstar.imperial. Thanks, Alice Trooper. This is fantastic. I can look at this. I've got a clear subject. It tells me what I need to do. Tells me where to email it. Perfect. I love that. This I friggin' hate, right? Oh my gosh, I don't want to read through paragraphs that have the same information in them, but I have to kind of like dig through it and the date when I need to do things, and it's not even clear. This says reminder. But like maybe you're reminding me that I need to eat dinner tonight or something, which I sort of already know. I hate getting you know email like this. I should have like bulleted lists of things are completely sufficient. I'm much, much, much happier with this. I know there's some faculty that really like to get kind of formal looking letters from students because I guess they're very old school. I get like dozens and dozens of emails every day, and the simpler the emails are, especially if I need to do something, the better. I hate having to dig through stuff like this. I especially hate when people send out reminders for events, and it's like there's an event that's happening at a particular time in a particular place in a particular day, and that information's buried in the. How do you expect anyone to show up if you're burying that information? You need to make that information clear. I can't keep that in my short-term memory. I'm not going to sit there and dig through this stuff to figure out when to. I get 100. Some days I get 100 emails. Good grief. Okay, that's what we've got. Thanks for listening.